Okay, guys, welcome to what? Are we on week 6, I believe? We are actually starting a new unit, and it is our last unit. You should be happy about that, right? We're in the home stretch. We're on unit 9, which is chapter 10 in your textbook, and we are in packet number 1. Okay, and this unit I'm going to split into 2 parts. First, we're going to start with exponents, and that'll be the first part of the packet. And then when you get packet number 2, it'll be scientific notation, and then we will be done. Let's flip to page 2. Okay. Again, you can print this out if you have access to a printer, or you can just put it right in your notebook. Okay, here we have 2 to the 4th power. And if you look at the 4, that's called the exponent or the power. Okay, and the 2, and this is important, that's the base. Okay, that's going to come up a lot in this unit. The 2 is the base. Okay, and 2 to the 4th basically means 2 times 2 times 2 times 2. And you can multiply that out any way you want. 2 times 2 is 4, times 2 is 8, times 2 is 16. Or you could do 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Okay, that's the basics. Okay, writing expressions using exponents. We're going to have, let's see, what is this? Expanded form. We're going to have exponential form. And we're going to have standard form. Okay, expanded form you write as repeated multiplication. Okay, so you can see here 3 times 3 times 3 times 3, etc., etc. That is called expanded form. If I want exponential form, I'm going to use, as you would imagine, exponents. So here we have 3, which is our base, and then we have 1, 2, 3, 4, 5 threes, so it's 3 to the 5th power. Okay? And if I ask for it in standard form, that means to actually evaluate the numerical portion. So 3 to the 5th is, if you'd actually take 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3. Anyway, the point is you would get the answer of 243. Okay? So that's how you do that. If we have 3/4 times 3/4 times 3/4, our base as a fraction, you need to make sure that you use parentheses when your base is a fraction, okay? So in exponential form, we would have 3/4 in parentheses raised to the 3rd power. And make sure when you raise something like a fraction to a power that you're taking 3 to the 3rd and 4 to the 3rd, okay? It applies to both top and bottom. So 3 to the 3rd is 27, and 4 to the 3rd is 64, okay? Here, we have a negative base, right? There's a negative base, but it's an even exponent because there's 2 of them. So it's going to end up being positive. And you'll see what I mean here. We have negative 0.3 to the 2nd power. Okay, so a negative times a negative is a positive. And then we have x to the 1, 2, 3, 4. So we have 2 bases. We have negative 0.3 and we have x. Negative 0.3 times negative 0.3 is going to give me 0.09 positive. And then we've still got our x to the 4th. Okay? Here we have 1, 2, 3 of them. We have a negative base, but an odd exponent. So it is going to end up being negative, okay? And I'll show you what I mean by that. We've got negative 2. Make sure you put it in parentheses. Raised to the 3rd power. And then we have 1, 2, 3 x's, so x to the 3rd and y to the 2nd. Okay, if you think about it for a second, negative 2 to the 3rd power. It's like negative 2 times negative 2 times negative 2. A negative times a negative is a positive. A positive times another negative is negative. So you're actually going to get negative 8, x to the 3rd, y to the 2nd. Okay? Now we're kind of going to work backwards here. Prime factorization, okay? We're just looking for factors. Okay, so this, you might have called this where you do a factor tree. You might have done that in 5th or 6th grade, okay? So I know that, well, I'm just going to do easy ones. I know 72 is divisible by 2. That would be 2 times 36, gives me 72. I can't go any further with 2. Here, well, that's an easy one. 6 times 6 is 36, okay? Here we can break that down to 2 times 3, and we can break that down to 2 times 3, and that didn't go any further. So our prime factorization is 2 times 2 times 3 times 2 times 3, okay, which is, what do we have? 1, 2, 3 2s. 2 times 2 times 2 times 3 times 3. There it is in expanded form. If I want to write it in exponential form, 2 to the third, 3 to the second, okay? I think you get the idea there. We won't do another one. Couple things to remember. Always, let's pluralize that. Always write the base in parentheses when the base is a fraction, okay? So like we had up here, we had a fraction. Make sure you put that base, which is the fraction, in parentheses. And this is also very important when the base is a negative number, okay? You're going to put that in parentheses as well, and I'll show you why in a second, why on the next page, okay? So let's go ahead and let's flip to page 3. This is going to be a relatively short video today because this is just kind of a review of stuff that you should already know, okay? Here we have, we're on page 3, okay? This was expanded form. Then we had, what's next? Oh, I'm sorry, 6 to the third. I changed the order on myself. That's exponential form. Then we'll say expanded form. Okay, and then we will have standard form, okay? So the exponential form, 6 to the third, for example. If I have it in expanded, it's repeated multiplication. Repeated multiplication, we'll say. And that would be 6 times 6 times 6. And then in standard form, we actually evaluate the numerical portion. So 6 times 6 is 36. 36 times 6, 216, okay? That was a nice, easy one, right? Positive, no big deal. Okay, compare it to a negative 6 to the third, okay? That negative is not in parentheses. So that actually, if we were to write it in standard or in expanded form, it's a negative 1 times 6 times 6 times 6, which gives me a negative 216, okay? Because that 3 is only attached to the 6. Because that negative isn't in parentheses, that 3 doesn't attach to it. As opposed to this, which we have a negative 6 in parentheses raised to the third power. That is if I'm writing that 3 is attached to everything. Negative 6 times negative 6 times negative 6, okay? That is attached to everything. We have a negative to an odd power, so that's going to give me positive 36, negative times a negative, times negative 6, which is going to be negative 216, okay? So those are very different. You have to make sure you put the parentheses, and when there is a parenthesis, that 3 attaches to it. So again, use parentheses whenever the base is negative or a fraction, okay? We won't do all of these. We'll do just a couple. Exponential form, okay? That negative, that 4 is not attached to it. So we have a negative 1 times 5 times 5 times 5 times 5, which is going to give me negative 625, okay? Got negative 1/7 to the third. That is attached to the negative. So we have negative 1/7. Remember, fraction, so and a negative. So you have to use parentheses. Negative 1/7, negative 1/7. A negative times a negative is a positive. A positive times a negative is a negative. We're going to get negative 1 over, what is that, 343. Okay? Here we have a negative 4 to the fourth power. It's in parentheses, so that 4 applies to everything inside the parentheses. We've got negative 4 times negative 4 times negative 4 times negative 4. Okay, you can think of it like this. It's an even power, so it's going to end up being even or positive. But if you even want to do it this way, negative 4 times negative 4, 16. Negative 4 times negative 4, 16. 16 times 16, 256. Okay, so that's kind of how we do these types of problems. I want to skip down to letter E. Okay, we've got a negative 7 times a negative 7. Okay, and negative 7 times a negative 7. That's going to be negative 7 in parentheses because there's 2 negative 7s raised to the second power. We have 1, 2, 3, 4. So the x is the base, raised to the fourth power, and a y times y to the second. Okay? So negative 7 squared is 49, x to the fourth, y to the second. Okay? I think we've had enough of that. We are actually in the home stretch here. This is going to be a very short video. We're going to do a few order of operations. We're on page 4. Okay, when we do order of operations, we've got to remember our PEMDAS, which is parentheses. You did this, gosh, you've been doing this for years, right? And grouping symbols. And I say grouping because there are things like absolute values, and you do everything that's grouped inside of that. We've got our exponent or power, okay, and roots. We've got MD, which is multiply and divide from left to right. Okay, and then AS is going to be add and subtract. And that's also from left to right. Okay, so let's just look at letter B. I'm going to skip around a little bit. We don't need to do all these. This is kind of review. Okay, 5 plus 6 squared divided by 4. We are going to do our exponent or power first, right here. So we've got 5 plus 6 squared is 36 divided by 4. Division comes before addition. 36 divided by 4 is 9. 5 plus 9 equals 14. Okay, these are kind of fun little problems. Let's look at C. As needed, write exponent as repeated multiplication if you don't know what 3 to the 4th is, for example. Okay, so we have a negative 3 to the 4th. That 4 is not attached to the negative. So I'm going to take, that negative stays out front. 3 to the 4th is 81. Negative 81 divided by 27. We've got our absolute value bars. Negative 81 divided by 27, negative 3. Okay, and the absolute value of negative 3 is positive 3. Now, something to keep in mind, although it wouldn't have actually ended up in resulting in a different answer, if that negative 3 would have been in parentheses, then the 4 attaches to the entire negative 3, okay? It just depends whether your base is in parentheses. Okay, let's flip. Just do a couple more. Let's go to page 5. Okay. Oh, this is a great problem. Let's look at letter G. Okay, again, we're on page 5. And as needed, write negative 2/3. Exponent part is repeated multiplication. Okay, so what that means is we have negative 2/3 times negative 2/3 times negative 2/3. Okay, 2 times 2 is 4, times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. We've got a negative times a negative, which is positive. Positive times a negative is negative, so we've got negative 8 over 27. Okay, I'm just going to go ahead and plug that in. Negative 8 over 27 plus, you've got to do what's inside. That actually came first. What's inside your grouping symbol? We've got a 5 squared. Let's just do it in a different color even. We've got 5 squared minus 2 times 15. Okay, so I'm going to write negative 8 over 27. Let's see, plus absolute value, 5 squared, 25. Multiplication comes before subtraction, so we have minus 30. Okay, I'm going to keep carrying down that negative 8 27ths. 25 minus 30, a negative 5. You know the absolute value of anything, which is the distance from 0, is going to be positive. So we have negative 8 over 27 plus a positive 5. Okay, and let's see, what do we got here? 5 minus 8 over 27 is going to give me, I always cross that off and do 4 and 27 over 27. That's going to give me 19. So my answer is 4 and 19 27ths. Okay, that was a little tricky. If you want to write that as an improper fraction, you can do that too. Okay, you get 27 as a common denominator. I don't care. Okay, letter H. 1/2 times 4 to the 3rd minus 6 times 3 squared. Okay, we've got a 1/2. Got to do what's inside those parentheses, and you do your exponents first. 4 to the 3rd is 64. Minus 6 times, we have to do our exponents. 3 squared is 9. Okay, multiplication comes before subtraction. So we've got 64 minus 6 times 9 is 54. 1/2 times 10. And we're going to get an answer of 5. Okay, so the bottom line is I want to make sure you guys have remembered your order of operations because now we're adding exponents to those order. Letter I, let's see. We've got some absolute value here. If you would like to, you can write negative 1/2 times negative 1/2 times negative 1/2. And then that's divided by 1/4. Let's see if I can squeeze that in there. I can't, so we'll just do another bar. Okay, negative 1/2 times negative 1/2 times negative 1/2 is going to be negative 1/8 divided by, let's see, we've got 1/4 times 1/4, which is 1/16. Okay, now remember, dividing, we're talking about fractions. We multiply by the reciprocal or keep change flip. We've got a negative 1/8 times a 16 over 1. Okay, I hope you see that you can cross simplify. Okay, so that's going to give you the absolute value of negative 2. The absolute value of a negative is a positive. So the answer is 2. Again, that was a good little problem. Okay, I think you should be seeing the theme here. We can do one last problem and then we'll be done for the day. And I'm doing this one because it's tricky. Okay, we've got negative 2/3. Okay, can you see that? Okay, yeah. And then we've got 1 to the 10th. Okay, well, 1 to the 10th, 1 to anything is just 1. Plus 9 minus 2 cubed, which is minus 2 times 2 is 4 times 2 is 8. Okay. And then we're going to square all of that. Okay. Bring back down my bars, my grouping symbol, negative 2/3. Let's look inside. We've got 9 plus 1 is 10. Let's write it out so you can see it. 10 minus 8, absolute value bar squared. Okay. 10 minus 8 is 2. So negative 2/3 times 2. Okay, negative 2/3 times 2 is going to be negative 4/3. Right? Yep. Squaring that. Okay, the absolute value of negative 4/3. Absolute value comes first. That's a grouping symbol. It's going to be 4/3. Can't forget to square. That's going to be 16 over 9. Okay, another fun little problem. And I think that's plenty for today. That's about 17 minutes. And I will talk with you soon.